Okay, let's begin with the second page. It is important to know how to convert units of area and volume when we are doing our calculation. Before we talk about conversion of units for area and volume, let's do a recap. How do we convert from cm to meters? Okay, so for example, what is 1 cm in meters? What is the answer for this? 0.01. Okay, and what is the step? Divided by 100. Okay, what about the other way around? Times 100. Okay, good. What about from 1 meter in kilometers? Okay, we divide by how much? 1000. So the result will be 0.001. And the other way around, we've got multiplied by 1000. Okay, how about from, for example, 1 kilometer to centimeters? How do we go about doing this? So kilometer, we expect that to be many, many centimeters, right? So it has to be a multiplication. But what do we multiply it by? 10,000? How do you get 10,000? What if you break it down into steps? Okay, so for kilometers, we go to the intermediate unit will be meters. And how do we get from kilometers to meters? We multiply by 1000. Then from meters to centimeters, we multiply by another 100. So another 2 zeros. So since we multiply by 100,000 to get from kilometers to centimeters, the other way must be a division by 100,000. Okay? So this is our recap for meters, centimeters, kilometers. Do you need me to talk about millimeters? How many millimeters in 1 centimeter? How many millimeters in 1 centimeter? You can use your ruler, right? There are 10. 10 millimeters in 1 centimeter. Okay? Now, next question. Over here. The common units for area. You have also done this before in primary school. Okay, so some common units we have millimeters square, centimeters, or rather square centimeters, square millimeters, square meters, square kilometers. Okay, the proper way to call it will be square something, not meter square, centimeter square, so and so on. Okay. Okay, now the next part. Look at these two squares. The first square has a length, or rather the side, 1 meters. And of course, the other sides will also be 1 meter. That's how you get a square. For the other square, the length is 100 centimeters. Okay, by 100 centimeters. Do you think the value of the area is the same? Do you think the area has to be the same? Think about the first square. The side, 1 meter. Think about the other square. The side, 100 centimeters. Are they the same? Is 1 meter the same as 100 centimeters? Oh, well, if the length are the same, are we talking about the exact same square over here? Therefore, our answer for this will be yes. It has to be the same because they have the same measurement, just a different unit. Okay. Now comes the interesting part. Here, let's fill in the blank. 1 meter is the same as 100 centimeters. Yes. How about now? Better? Okay. So over here, we've got the length of the side. 100 centimeters is the same as 1 meter. So we expect both squares to be exactly the same size. So the area must be the same. But when it comes to the calculation of the area, what is the area for the first square? Okay, learn that is length and breadth, isn't it? So this is 1 meter times 1 meter. This will show you number times number. Then letter times letter. Just like in algebra. Okay? So let's start with the 1 times 1. What do we get? Has to be 1. N times N. What do you think we get? M algebra, we multiply the letters together. And then we give it meaning, this is 1 square meter. Now let's move over to the second square. We've got 100 centimeters times 100 centimeters. Area, we learned in primary school, left hand breadth. So 100 cm times 100 cm. Same concept. Number times number. 100 times 100 gives us 10,000. Here you see 4 zeros over here. Now what about the cm? Cm is a unit. Cm times cm. Something times itself. That will be a square, isn't it? So we get 10,000 square centimeters. Okay? Now we answered yes to the previous question. The two areas are the same. So what can you tell me about 1 square meter in terms of square centimeters? Is 1 square meter equals to 100 square centimeters? It cannot be. We have already shown from this example that 1 square meter must be the same as 10,000 square centimeters. So here, blank will be 10,000 square centimeters. Why do we even spend time talking about this? Because the common mistake, the most common mistake when we come to this type of question is saying that since 1 meter is equal to 100 cm, many students think that 1 square meter must be 100 square centimeters. This is the problem. Let us try and find out exactly what 100 square centimeters look like. Okay? 100 square centimeters, if this is the area of the square, if 100 square centimeters equals the area of square, then the side equals to how many cm? 10. How do you get 10? Square root. You square root 100 square centimeters, you get 10 cm. Okay, now, what does a 10 centimeter square look like? Let's go look at this. 10 cm by 10 cm. Compare that to a 1 square meter square. So this will be 1, 2, 3, 4. Oh, this is only 5. Now wait. Can you tell how much difference this is? Okay, so here we got 2, 3, 7, 8, 9, and 10. 1, 2, 3, 4. 1, 2, 3, 4. This over here we got 100 cm by 100 cm. The big square over here is 1 meter by 1 meter, which is 1 square meter. If you ever tell me that it is equivalent, if you ever tell me that 1 square meter is equal to 100 square centimeters, you're telling me that these two squares are the same size. It cannot be true, isn't it? They are obviously different. Okay? Okay, the next part, common units of length, we've already talked about it. We've got our kilometers, we've got meters, centimeters, millimeters. Okay, so we like to use arrows like this to show us how we convert from one form to the other. Okay, so after you've drawn this, please fill in the blanks in the arrow, then check your work against mine. Okay, this is what it looks like on conversion from kilometers to meters to centimeters, then to millimeters. We multiply because we expect the numbers to get bigger and bigger. So the other way around has to be division by the same value. Okay, now since we have already done this, equals to 10,000 square centimeters. Can we try converting from 1 square centimeter into square millimeters? How are we going to do this using the same approach as above? So the method is to draw a square, a 1 cm by 1 cm square. So this has the area of 1 square centimeter. Now, it has to be the same square, right? Because there's an equal sign. What is the dimension in millimeters? From 1 cm to millimeters, what is the value? 10. So on. This side, the must also be 10 millimeters. So what is the area of a 1 square centimeter square in square millimeters? Then my mental sums will be 10 square. Okay, which is 100. There is a reason why I write 10 square over here. Okay, but for now, let's just put it as 100 square millimeters first. Think about it. Why is it 10 square? Where did the 10 come from? Came from the conversion of 1 centimeter to millimeters. So because we are going to multiply by the same value, it is a square. Therefore, it is 10 square. Okay, now we go back to what we originally had. 1 square meter equals to 10,000 square centimeters. How else can we rewrite this 10,000 in terms of the square? So instead of writing 4 zeros over there, 1 0 0 0 0, I can write it as 100 square. Where did this 100 come from? It came from the conversion of 1 meter to centimeter. Do you see the picture? Okay, so now common units of area, we're going to go from kilometers, square kilometers, to square meters, to square centimeters, to square millimeters. We're going to draw the same arrows again. Okay, now look at the screen. We have just done 1 square centimeter to square millimeter. We found out that it was times 10 square. The reason why I write it as 10 square instead of 100 is because I want to remind you that in 1 cm, not in 1 square centimeter, in 1 cm we got 10 millimeters. That's why there's a 10 over here. Similarly, from square meters to square centimeters, we multiply it by 100 square. You can write 10,000 if you want to. But by writing it as 100 square over here, it reminds us that in 1 meter, not in 1 square meter, in 1 meter we got 100 centimeters. Now your turn, fill in the blank over here. What is the conversion from square kilometers to square meters? Multiply by what? Yes, 1,000 to square. Okay? Since we have gotten the conversion from square kilometer, square meter, square centimeter, square millimeter, can you go the other direction in reverse? And fill in the blanks. This is an important concept because later on you'll be converting from, for example, math skills. You do geography, right? Geography, you will have a scale, 1 centimeter represents 1 kilometer. They may also ask you about the area. So you need to know how to convert units of area. Okay, so once we have that ready, this portion shouldn't be a problem. Let's do it quickly. And you know what? I'm going to pause over here. We're going to take 1 minute to try and fill in everything. Okay? So over here, 1 meter is the same as 1,000 millimeters. Milli, if you remember your physics, refers to times 10 to the power negative 3. You learn this in physics, in science? And you should have milli, M-I-L-I, refers to divide by 1,000. So here, millimeters we times 1,000. So we square it. 1,000 square will be 1 million. Now, 1 million square millimeters is equal to 1 square meter. Now they want 360,000 square millimeters in 1 square meter. So we go from here, divide, multiply. So the answer will be 1 over 1 million. With 6 zeros at the bottom. Multiply by 36 with 4 more zeros. So cancel with 4 zeros, we get 0.36 square meter. Just proportion. So let us, okay, now. The whole point of this part is to show you how to convert from square kilometers to meters and so on and so forth. If the question didn't ask for this, if they didn't ask for this, are you able to solve the third line directly? If you can, good. That means you have already memorized and you have learned how to do the conversion by yourself. If you are unable to do the last part straight away, don't worry. Just make sure you get the second line correct. Once you get the second line correct, then it's just direct proportion. For example, from the second line to the third line, if 1 square kilometer is 1 million square meters, then half of a square kilometer must be the division by 2 over here. And likewise for the second case, we are multiplying by 2.5. So on this side, we multiply by 2.5. Same. Okay? So I'll demonstrate for the first part A. 7.5 square meters in square centimeters. I'll write down the question, 7.5 square meters. Now, instead of going straight away to square centimeters, I want to convert the square meters to centimeters first. This means I keep the number. Okay, the number says 7.5. This meter over here, this square meter refers to 100 cm times 100 cm. This is what 7.5 square meters means. I am converting the meters. No, I'm converting the square meters to 1 meter times 1 meter. I change the 1 meter to 100 cm times 100 cm. From here, then I get my answer. 7.5 times 10,000. So we get 75000 square centimeters. This is one way that you can do it. The other way, of course, is if you have already memorized 1 square meter equals to, we multiply by 100 square. Whichever you prefer. For me, I don't really like to memorize, so I'm actually doing this in my head. Okay, the second one, 0.5 square meters. And go directly 0.5 times 100 square. And this will be square centimeters. So the answer is 5,000 square centimeters. Okay, this is true. Memorize it. This is by deriving on the spot. Any method you like. Okay, can you try part C, D, E, F, G, H. C, D, E, F, G, H now. Okay, who needs more time over here? Alright, let's move on. Conversion over here again. Now 10 square meters to square centimeters. We use the same approach. 10 square meters. Pretend we are converting from meters to centimeters. All of us know how to do that. Multiply by 100, isn't it? Meters to centimeters. But this time it is meters, square meters to square centimeters. So you multiply by 100 square. And this will be cm square centimeters. So we've got 4 zeros over here, 5 zeros. 1, 2, 3, 4, 5. This is by far one of the most straightforward and fastest way to do it. divide by 100. And so we go from cm to meter. But because this is the area, we square this. Square your 100. So we move the decimal place by 4 digits. 1, 2, 3, 4. 2.5 square meters. 0.36 square meters. Pretend we are converting to length. So we divide by, we multiply by 100 and we square it. Total of 3600 square centimeters. Finally, for part D, (580 square centimeters). Pretend that we are converting from cm to meters, so we need to divide by 100, but because it is area, we square it. So move by 4 places. 1, 2, 3, 4. Get 0.058 square meters. Okay? Can you imagine how we are going to convert volume? Now that we are sure about area, what do you think volume is going to be like? We have the same approach. Okay, later on we'll look at it. Maybe not in this set of notes. Yeah, not in this set of notes. In chapter 13, we'll be dealing with volume also. Okay, so now this is the main part of today's lesson, because the subsequent part is area and perimeter of composite figures. Composite just means that we have a combination of different figures. We are already familiar with the perimeter and area for our quadrilaterals, including rhombus, parallelogram, trapezium. Okay, so before we move on, let us do a recap again. What is the area of square? What's the area of a square? Okay, length times breadth, or because the length and breadth is the same, isn't it? So let's just call it L square. Area of rectangle must be length times breadth. Area of what's the next one you learned? Parallelogram. Okay, what is the formula for this? If I have this as a parallelogram, this is the length, and let's call this side A. Are you able to tell me what is the area of this parallelogram with the following information? Is there enough information? Hey, come on guys, is there enough information? You have to be able to tell me yes or no. Yeah, there's not enough information. Because the formula for area of a parallelogram is given by base times perpendicular height. Okay, now, if I extend this out this way, and I drop a perpendicular line. Okay, doesn't really look perpendicular over here. Let me try again. And I call this H. What is the area of this parallelogram now? This is A over here. What is the area of this parallelogram? Is there enough information even? Yes, there is. Then what is the answer? H multiplied by, is it A or L? A. How do we decide? First, we need to select a base. This is my parallelogram. It has 4 sides. Any one of them can be the base. But different base will give you a different perpendicular height. Most people will select L the horizontal line as the base. Because it is drawn this way. Well, if I drew my parallelogram this way, would you say that A is the base? It depends on how you rotate it, isn't it? So for the same parallelogram, we have 4 different sides. All of them can be the base. Because I drew it this way, many of you would like L to be the base. Fine. If you choose L to be the base, you must be able to identify where the perpendicular height is. The perpendicular height starts from the opposite side of the parallelogram. Where is the opposite side? This is the opposite side to L. Again, if you choose L as the base, then the yellow part is the opposite side. From there, we drop a perpendicular line. Why do we keep saying drop a perpendicular line? Because I am really dropping something. Okay? You know in physics, you've got this thing called gravity. Everything drops to the ground, isn't it? You throw something up, it drops to the ground, right? Does it drop vertically down or does it drop in a slanted manner? When you drop, I'm not saying throw, when you drop, it follows directly down, isn't it? Here I have my lanyard. It actually forms a perpendicular to the ground. The ground is horizontal. This is definitely perpendicular to the ground. This over here is 90 degrees. So when we say drop a perpendicular from the yellow line down, okay, so we start anywhere, over here, I drop. This is my perpendicular. From the yellow side down to the base. Now my base, I can extend this out. So this distance over here will be my perpendicular height. Okay, this perpendicular height can be shifted and it is the same throughout over here. Can you see that? It is the same. Even if I extend this side out, I will get the same perpendicular height. That is, if I choose L as my base. If I choose to rotate it, I rotated it. Now if I choose this as the base, ignore the yellow portion. If I choose A as the base, then the opposite side is over here, the other parallel side. Same thing, I start from the opposite side, I drop a perpendicular. This is my perpendicular line, and this distance is my perpendicular height over the H. Okay, we can extend this part out, and we get the same height. Okay? So with this piece of with these two information given to you, I give you A and I give you H over here, it is enough for us to determine the area of this parallelogram. In fact, this concept is used also in calculation of area of triangle. Let me just complete this first. So you have to be able to see things, see the same shape in different orientation. Move your paper around if it helps you. After you practice enough, you don't have to rotate your paper anymore. You can visualize it, you can rotate it in your mind already. Okay, so in this case, the area of the parallelogram is A times H for this particular drawing. Okay, then area of a trapezium is the half times sum of parallel sides times the perpendicular height. Okay, this H over here, I actually prefer to write it as perpendicular height. Okay, battery is flat. Okay, then one more for the rhombus. It is given by, is it the product of the sides for rhombus, or is it product of something else? Area of rhombus. What is the formula given by? So this is a rhombus. If this is A, this must be A, this must be A, and this must also be A. Because the property of the rhombus is that they all have the same sides. The other property that we know about rhombus is that the diagonal lines, they bisect each other at 90 degrees. They cut each other into two exact halves. Okay? From here, we can rearrange the triangles. And we've gone through this rearranging of the triangles to form another quadrilateral which we know the formula to. Okay, so for this, go and watch the video again if you cannot remember, but it is the diagonal one, the first diagonal multiplied by the second diagonal. Okay, but is this the end? There's something else, right? What is it that I have to multiply this by? How? Okay, so these are the formulas that we need to use for calculation of area. Here's a summary. Okay, next. I also mentioned about triangles. For a triangle like this, it has three sides. Let's call it A, B, and C. To calculate the area of this triangle, I definitely need more information. A, B, and C itself is not enough. Harry, what would you like as the base? A, B, or C? You want to choose C as the base? Okay. If he chooses C as the base, then maybe if I rotate it this way, it's easier for you to see, right? If C is the base, we need to now decide where the perpendicular height is. And again, I use my lanyard over here to demonstrate how we drop a perpendicular from the opposite side. Same as the parallelogram. If this is the base, we go to the opposite side over here. From here, we draw a perpendicular line. This is my perpendicular height. EC is the base. Now, of course, we could have let A be the base also. If A is the base, where's the perpendicular height? We go to the opposite side, the side that is not used. Put it over there, drop a perpendicular down. Now you notice that there's nothing over here. So we have to draw a dotted line, and this portion is my perpendicular height. It is a different perpendicular height if the base is C. We've got one last option, which is B. If B is my base, opposite side over here, drop a perpendicular, extend this line, and this over here is my perpendicular height. Can you see the triangle has three bases and three different heights? Unless it's an isosceles triangle or an equilateral triangle. So you have more of the same base and more of the same height. So this is all that we need to know for our recap. Now we're ready to see what kind of combinations we can have. Okay, first one. In the area, in a figure, we've got AD at 6 cm. So note the units. EC is 5. Okay, AE is 4. EB 3. Find the area of the quadrilateral ABCD. I think they didn't tell you something. Okay, so let's just include that. Oh no, wait. Question: is AECD a trapezium? Is it a trapezium? How do you know? I see you nodding your head, but how do you know it's a trapezium? A trapezium requires us to have parallel sides, isn't it? But how do you know those are parallel sides? So what if it's a right angle? Yeah, I see this is a right angle, so corresponding over here. Do you see the letter F? So if this angle equals to this angle, which happens to be the case, then by the, and it's important, by the converse means the reverse, by the converse of corresponding angles parallel lines, we now know that AD must be parallel to EC. Only because those two are 90 degrees, then we can come to that conclusion. Then we can use the area of a trapezium to answer this question. Okay? Now for my own question. What if this is not 90 degrees? What if this is actually 89 degrees? Is this going to be a trapezium? No, because by the converse of corresponding angles parallel lines, they are not the same angle. Therefore, they are not parallel lines. Therefore, it can't be a trapezium. Then we won't be asking you to solve this question anymore. Okay? So now we don't need you to prove that it is a trapezium, but I need you to have that thought process. So now that this is a trapezium, find the area of A, B, C, D. It is made of two shapes, right? Let's find the area individually. So area of the trapezium AECD. A, E, C, D. And I want to highlight that when you call a shape over here, I gave it a name, I call it AECD. You must go in one cycle. You cannot call it AEDC. Okay, you must go in one cycle, either this way or clockwise. Of course, you can choose to start from any point, but no matter what, you cannot call it AEDC. You cannot go this way, because then you'll be describing a different shape altogether. Okay, so the first shape we have is a trapezium. Half times sum of parallel sides, 6 plus 5, times the perpendicular height, which is 4. The perpendicular height for a trapezium can be identified using the same process. Okay, dropping a perpendicular from one parallel line to the other parallel line. So here we can work this out. This is 11 times 2, 22 square centimeters. Area of triangle CED. R times the base times the height. So this is 15/2. Total area, we add them up, 29.5 square centimeters. Can we combine these 3 steps into 2 steps or 1 step? Can, because it's straightforward enough. But I must see that you know what to substitute in for the formula of the area of trapezium, as well as area of the triangle. Practice 2, 3, and 4 will be your homework for today. Practice 2, 3, and 4.